Pay attention to this. Today's space launches are a bad idea, and actually, there's another way to do it more efficiently. Launching a rocket from a plane at altitude, then having it ascend after detaching. This video explains why, despite being more efficient, few people use it yet. Space launchers are a necessary evil for engineering. To put a satellite into orbit, as we explained in previous videos, it's necessary to get it moving at a very high speed outside the atmosphere. And for now, the only way we know to do this is with these powered launchers. Today, two options have been used successfully. The first is a rocket launched vertically or nearly so. What we're used to seeing, and that's why I'll call it a conventional launch. And the second is to use a plane that carries a rocket up to a certain altitude. And there it detaches, continuing to ascend until it reaches orbit. This system is called air launch, or in English, air launch to orbit. Something I couldn't understand until I started researching. In this video, I explain why we haven't switched to the airplane option yet. The most fuel-efficient aircraft are airplanes. This is because the fuel used by the engines is used to move the aircraft. The speed relative to the air generates lift on the wings, for example. The force generated by the two engines of an A350 is 400,000 newtons, and the maximum weight with which the plane can take off is about 3 million newtons. Which means that the lift is about 8 times greater than the thrust. On the other hand, rockets that go up vertically do so with an acceleration of about 3 Gs, which means that the thrust is 3 times greater than the weight. So airplanes with a little thrust can lift a lot of mass, but rockets with a lot of thrust can only lift a small amount of mass. Every time I thought about this, I couldn't understand why we kept using rockets that go up vertically. Since the main goal of launch vehicles is to put satellites into orbit, it's important to understand the following. Rockets with conventional launches that go to low Earth orbit only manage to put about 3 or 4% of the rocket's initial mass into orbit. For geostationary orbits, which are much farther, the percentage is about 1%. For example, the Falcon 9 rocket weighs about 550,000 kilograms, but it can only carry 22,000 kilos to low Earth orbit and 8,000 kilos to geostationary orbit. So increasing that percentage of mass put into orbit even a little would mean a radical change in the aerospace sector. First of all, what you want to achieve with space launchers, as I already mentioned, is to take your satellite to a certain altitude at a certain speed in order to enter orbit. Rockets follow a straight line, which is the shortest path. That's why time in the atmosphere is minimized, because aerodynamic resistance slows the spacecraft. But be careful, because let's not forget that the rocket also has to gain speed, not just altitude. Going up vertically is hard to accelerate because you're directly fighting gravity. That's why the rocket is tilted to boost speed, even if it ascends more slowly. This is also used to begin directing it into orbit. But in this way, by going faster and also taking longer to leave the atmosphere, the aerodynamic resistance will be greater. How much should you angle the rocket? It's an optimization problem between minimizing the losses caused by gravity and minimizing the losses due to aerodynamic resistance. Of course, these things are solved by computers that take thousands of variables into account. They're not usually solved by hand. As discussed in the previous video about rockets, multiple stages are used to optimize reaching orbit. But then, knowing this, what are the advantages of an air launch system? Surprisingly, there are many. You're not dependent on weather conditions to take off. We've seen many times that because of storms or wind, a lot of conventional space launches have been postponed. This is especially frustrating since of the rocket's hundreds of kilometers ascent, only the first 8 kilometers have bad weather. After that, there are no storms, and for this reason, what if an air launch system was used? The plane would take care of climbing above the clouds, and then the rocket would be released to begin its ascent. You don't need to have a launch platform to put a satellite into orbit. Only about 15 countries in the world have access to them, and therefore very few countries can put satellites into orbit. By launching from the air, you only need a runway, since every country has airports. Every time a launch is made, there is an area known as the no-go area, which represents the entire area where if something goes wrong, there would be danger. And normally these areas are usually evacuated. With rocket launches from airplanes, this area would be much smaller, and also the aircraft could be moved away from all nearby populations to carry out the launch. And that way it wouldn't bother anyone. This is, without a doubt, the most important one. The entire lower layer of the atmosphere, where the air density is higher, is crossed by a plane, which is much more efficient. Afterwards, the rocket is deployed, which can already have the nozzle optimized for low atmospheric pressure. This depends on the nozzle's exit area. As external pressure drops, the nozzle should widen. When launching from the ground, pressure changes from 1 bar at sea level to a vacuum, and the rocket experiences this whole range. At around 12-kilometer altitude, the low pressure means the nozzle is already optimized for those conditions. We have a series of videos about nozzles on the channel. Well, with all these advantages, why is this type of launch more profitable for us? The truth is that it is more profitable, but only by about 5%, according to what Elon Musk said. After having studied this option for spacings and a 5% profitability along with the previous 3 advantages, it's not enough to justify the complexity involved in the launches. Why is a modified aircraft needed for this? Typically, Boeing 747, Boeing 52S, or Antonovs are used for this type of mission. But of course, to be able to carry a rocket attached to the wing, you need to reinforce the structure to make sure it can handle the load. Also, the joint for rocket detachment would need to be designed. Also, the plane must be redesigned inside to remove extra weight and, most importantly, ensure proper balance. Placing a large mass on one side of the plane disrupts its stability. The rocket's release timing is crucial. It has been seen in past missions that when the rocket is released and ignited, it takes a few seconds to reach speed, so that it can maneuver and tilt upward to ascend and leave Earth. That's why it has been seen that it's best for the spacecraft to start raising its nose in the moments before separation, so the rocket doesn't have to tilt upward later, which wastes energy. If, for example, vector thrust is used to tilt, thrust would be lost, just to accelerate the rocket in order to orient it upward. If control surfaces were used on the rocket, they would create more drag and result in greater energy loss. But how much energy would be lost? Many studies have been done and the following has been observed. As always, understanding the graphs is key. On the x-axis, we have the pitch angle of the plane at the moment of separation, and on the y-axis, what is called the v-gain. It's the additional speed a rocket gets when launched in the air versus vertically from the ground. For example, for launches where the plane was traveling at 300 meters per second at separation, we have this line. This point refers to a horizontal rocket separation, meaning the aircraft hasn't tilted its nose upward. The extra speed compared to launching vertically from the ground is about 800 meters per second. However, if right before that we make the aircraft tilt its nose upward about 30 degrees above the horizon, we'll achieve almost 1,200 meters per second compared to a conventional launch. Which means that just by pointing the nose of the aircraft about 30 degrees, you get about 400 extra meters per second. And that's why you'll always see this being done when launching from the air. But actually, launches from aircraft have a big problem, and honestly, I think this is what limits them. The mass and size of the rocket they can carry. As much as possible, it might be about 1.5 meters tall at most under the wing. However, a Falcon 9 rocket has the capability to put monstrosities into orbit. Remember that a few years ago, Elon Musk's Tesla Roadster was put into orbit, and that's where conventional rockets become strong. Once Starship is operational, will it be able to launch large satellites into orbit? That's why it's not about choosing between conventional or air-launched rockets. Both methods are effective in their own areas. It's hard for countries without launch platforms to put up small satellites. Airplane launches are a great solution. However, for projects that require power, conventional rockets are still king, although it's fair to mention several things. The first is that the current largest airplane in the world is the Strato Launch, an aircraft specially designed to launch other aircraft from the air. This enables progress toward launching larger rockets into orbit. It has an almost 120-meter wingspan. It can make the Antonov 225 look small. Currently, this aircraft will focus on being the test platform for hypersonic aircraft. Since in recent years, there are quite a few companies that seem interested in this technology. And these aircraft need to start at a certain speed already. They can't take off from the ground. And the other point to mention is that while researching for this video, I came across a great idea for air launches. It involves using cargo aircraft as launch planes. For example, the C5 Galaxy is suggested with the rocket placed inside the aircraft. This eliminates the need to modify the wing structure for rocket attachment. It would just be placed inside on rails. Once the plane reaches the right speed and altitude, the rear hatch opens and the rocket inside is released. Hooked onto the rails, it would release a small parachute out of the plane that would pull it backward. The parachute would be hooked to the rails, and as it exited the aircraft, the rocket would detach from the rails. It would be ideally positioned to ignite the engines and ascend safely, avoiding both the parachute and the aircraft, which would have already moved ahead. Once it ascends high enough, the fuel tanks would detach and fall so they can be recovered while the satellite reaches orbit. If you look closely, the aircraft wouldn't need any changes. Could a standard C5 be used? And this is something very positive, since having a specific different aircraft generates a lot of costs. However, if you can use a regular aircraft, the cost of putting something into orbit would drop significantly. This idea has been called Swift Launch, and we'll have to see if it actually develops in the coming years. I find it interesting. In engineering, there isn't always a definite answer. If conventional launches are still being used, it's because overall they're better than air launches. Don't just focus on the car's fuel consumption. That's a small factor, but there are actually many more, like manufacturing costs, design costs, and so on. The same thing happened with aerospike rockets. About a year ago, I made 2 videos about them. And yes, indeed, they're also more efficient than regular rockets, but they're not used for the same reasons. There are many more factors. By the way, do you remember what I mentioned to you at the beginning of the video? Is using rocket launchers now the only way to put satellites into orbit? Actually, no. In the next video, I'm going to talk to you about some new ways that are being considered to put satellites into orbit. Subscribe now so you don't miss out. Are you watching from the future? And you're watching this video months after it was published, you're in luck because you already have this video here. Thank you very much for your time, and I'll see you in the next video. One more thing before I go. For all of you who want a channel similar to mine, let me tell you that you have the engineering channel. Real Creai, creator of the Real Engineering channel with more than 3 million followers, is now publishing his videos in Spanish on this new channel. This channel was a major inspiration for what I'm doing now. If you enjoy engineering, you'll love the content.